you, but when I saw Wonder Woman come out, I was extremely impressed with her strength and capabilities to move quickly, and just also her courage.
Right. We're gonna put this on our backs, and when I say go, lift hard. Diana! Shield!
And today, we are going to be calculating her initial velocity using 2D kinematic equations. So check out what Sheila has to say for our equations.
Hi everybody, Sheila here. So after we watched this scene, we wanted to figure out what Diana's initial velocity would have to be when she jumps off the shield for her to get to the top of the church, assuming that her velocity when she gets to the top of the church is 0 meters per second. So to do that, we set up this diagram, this very artistic and scientific diagram, as you can see, where we have the height of the shield that she jumped off of and the height of the church, and then we can see her displacement in the x and y directions and the path that she jumps to get to the top of the church. And so to do this equation, first we wrote out the things that we know. So in this equation, we have a distance in the y-axis that we estimated to be 7.5 meters, which we got by taking the height of the church at 9.3 meters, and then taking away the height of the shield, which we estimated at 1.3 meters to give us a final height of 7.5 meters. So that acts as our displacement in the y direction. And then we calculated our time to be 2 seconds. Now the scene is actually shot in slow motion, which is typically 120 frames per second, which is 2 times faster than the normal frame rate of 60 frames per second. So our time in slow motion is actually like twice the time you would see in something that's shot at a normal speed. So we calculated our time to be 1/2 of the time that we see on screen. So that's how we got the 2-second time. And then looking at the acceleration, we don't have any acceleration in the x direction, but in the y direction we have the acceleration of negative 9.8 meters per second squared, which is the acceleration of gravity. So after we figured out all of our knowns, we moved on to figuring out which equation we should use. So we selected the equation of displacement is equal to v initial times time plus 1/2 acceleration times time. And then we moved on to calculating the initial velocity in the x and y directions. So we started with the y direction, and looking at our equation, we needed to rearrange it in order to have it set up to give us the value of v initial. So how that ended up looking is v initial is equal to displacement minus 1/2 acceleration times time over time. So we took all of our values from the y direction and plugged them into that equation, and ended up with an initial velocity in the y direction being equal to 13.6 meters per second. So after we got that value, we moved on to the x direction. And we used the same equation, and we rearranged it in the same way, but the term 1/2 acceleration times time squared dropped out because we don't have an acceleration in the x direction. So when we plugged in our variables, we just had the displacement over the time, which gave us an initial velocity in the x direction of 3.7 meters per second. So once we had both of the initial velocities, we moved on to merging them together to get what the actual initial velocity is. So looking at this, we kind of conceived of it as a triangle and used the Pythagorean theorem where the legs are the x-axis and the y-axis, and the total initial velocity is the hypotenuse. So we used a squared plus b squared equals c squared to get that. And so we plugged that information in and had the squared initial velocity in the x direction and the squared initial velocity in the y direction added together. And then we took the square root of that to get the initial velocity. So we calculated that the initial velocity for Diana when she leaps off of the shield to get to the top of the church is 14.09 meters per second.
A small note is that we are calculating the initial velocity for Diana to jump up to the building, not the initial velocity she would need in order to destroy it. That would be another video. Thanks for following us this far.